Bismillah ar-Rahman ar-Rahim. Today we are going to talk about another monitor for the acid base. We have mentioned these monitors. Now we are going to talk about the strong ion differences. Strong ion differences, when you look at this, we have strong ions and strong cations, and at the same time we have weak ions and weak ions, either cations or anions. But the problem here, what's meant by strong? Strong means that, like magnesium, calcium, potassium, sodium, these are strong cations because when they are present in a solution, they are present usually charged and they do not readily combine with the other ions. They are fully dissociated. So this is another important point. Fully dissociated and charged. But on the other hand, when you come to the weak ions, weak anions, by the way, or weak cations, they are not completely dissociated. So some of it are carry their charge, and the other not. They are present in combinations with the other ions. So this is the difference between them. This is weak, which does not dissociate completely. Strong, which dissociate completely, and they are charged. What about the strong ion differences? The difference between, when you look at the composition, as I have mentioned before, of the extracellular compartment, this is formed of cations and anions. And we have mentioned that there's some sort what we call electroneutrality, in which the cations equal the anions. But when they came to study it, they said if we calculate together, sum together the summations of all the cations, these stronger cations, sodium, potassium, calcium, magnesium, minus the strong anion, which is chloride, this is gives us the value 40. Because here, or simply, we can say the strong ion differences is the difference between sodium and chloride, because sodium forms the majority of the cation of the extracellular space, and chloride forms the majority of the anion of the extracellular space. So in this case, when you look at the difference between the two, the difference between the two is 40. The sodium is 142. Chloride is 102, the difference is 40. This 40 doesn't mean that this is sodium for sure is more, but this difference equals that value. This difference is the difference if the anion, this is a part of the anion should be added to the chloride in order to equal this cation. So this is the difference is not the difference between positive charge and negative charge to give you the best should be positive. No, it's not like that. This is the difference. This is the positive cations. This is the negative anion, and this is if you measure this minus this will give you that. Oh, this is 40. This 40 is the strong ion difference gives 40 milli equivalent. 40 milli equivalent to what? This is what we call the effective strong ion difference or buffer base to make it easy. This is a buffer base which is bicarbonate plus total weak acids, inorganic phosphates, and protein, which forms about 16 milli equivalent plus bicarbonate 24 gives you 40. So the strong ion difference is the difference between the two will give you this 40, which is 40, we can say this is 40 negative charge or 40 hydroxyl group. Because these when they dissociate in water, they give you hydroxyl group. This is an alkaline one. So this is the strong ion difference. But the difference between these strong ions and the buffer base, we have something here, what we call a strong ion gap. Strong ion gap, this is the measurements of lactate and keto acids, and usually their value is negligible, so the near the zero, so the strong ion gap is nothing in the normal state. But if you say this is a patient who are going to study it, a patient with ketoacidosis, lactic acidosis, it will be increased and can be measured, and this will be on the expense of bicarbonate. At the same time, we look at the anion gap. I mentioned before, there's a difference between sodium minus chloride plus bicarbonate. This will give you this one. What? The total weak acids, which is about 12 plus minus 4, which is 16. So this is the anion. So this is the relations between all these terms: strong ion differences, buffer base, strong ion gap, and anion gap. So again, to the strong ion differences, we should remember this is the difference between sodium minus chloride will give you the buffer base, which is 40. If it is more than 40, this is alkalosis. If it is less than 40, this is acidosis. Look at it. Strong ion differences, this monitor is used only as off value if there is some sort of a change in the anion gap, normal anion gap changes. This means that uh, the difference between the two, if there is some sort of increase in the chloride, this will make us chloride will increase, and the difference between sodium and chloride will be less than 40. Increase in the chloride, as in the cases of diarrhea. If there is some sort of diarrhea, there will be loss of bicarbonate, and concomitantly there will be absorption of chloride. So the chloride will increase and the bicarbonate will decrease. So this is the consistency of the solutions. This decrease in the bicarbonate, increase in the chloride, and this increase in the chloride will make the difference less than 40. And the buffer base, for sure, there is a decrease in the bicarbonate, and this fixed or constant, so the difference or the buffer base will be less than 40. Less than 40, this is acidosis, and it is clear that this is acidosis due to decrease in the bicarbonate. But from the strong ion differences, when we measured it, sodium minus chloride, which became larger now, so the difference is less than 40. So this is a normal anion gap change. Look at, on the other hand, if there is some sort of vomiting, the patient vomiting is losing chloride, so the chloride will decrease, bicarbonate will increase, buffer base will increase, it will be more than 40. This is alkalosis. When you measure the strong ion difference, sodium, which is normal, with decreased chloride, so it will be more than 40. This is a hypochloremic metabolic alkalosis from the strong ion differences, and also from the buffer base, which increased. The same thing when you look at the anion gap. The anion gap, this is the difference between sodium minus chloride and bicarbonate. This is a normal anion gap because an increase in the chloride will be associated with a decrease in the bicarbonate, and vice versa. So there is no change, as I mentioned before. Chloride plus bicarbonate 130, one increase, the other decrease, and the two is 130. This is a normal anion gap metabolic changes. So normal anion gap changes, this is the strong ion differences can be a monitor for it. But if there is some sort of high anion gap changes, high anion gap change, this means that there is increase in the keto acids or lactic acid or fixed acid, as in case of renal failure. These acids will react with bicarbonate. So it is increase in this strong ion gap and became of value now. It has a number, and this increase will be on the expenses of the bicarbonate. So the bicarbonate will decrease, and accordingly the buffer base will decrease, will be less than 40 by the increase of these keto acids or lactic acid or fixed acids. But when you look at the strong ion differences, no change in sodium, no change in chloride, which is normal. So in the high anion gap, there is no change in the strong ion differences, but the change in the buffer base. High anion gap we have mentioned here. The anion gap is the difference between sodium minus chloride plus bicarbonate. In the high anion gap, bicarbonate, we said that is decreased in the bicarbonate due to the increase in these acids. Whether this is fixed acid or non-fixed acids, all of them, they react with bicarbonate. So bicarbonate decrease, and for sure the anion gap became the anion gap increase, and this is high anion gap. So this is that there is increase in the anion gap due to decrease in the bicarbonate, right? But at the same time, this is the anion gap increased, but the buffer base decreased due to decrease in the bicarbonate, and the strong ion difference is the same. So this is take care when you study, when you compare strong ion differences and buffer base and anion gap and strong ion gap. Another important point which is not common when you add something like sodium acetate or sodium lactate or sodium citrate, something like that, the sodium load will increase, but there is no concomitant increase in the anion, which is usually not measured. But look at acetate, sodium will increase. The difference between sodium and chloride will for sure will be larger. Sodium, instead of being 142, say 150, something like that, and this is the same. So this will lead to what we call metabolic alkalosis. And this how can you define it? We mentioned before that acetate dissociate sodium acetate dissociate into sodium acetate into acetic acid and hydroxyl group. So there is increase in the hydroxyl group, and this buffer bases and hydroxyl group should be increased. But we measure here bicarbonate and measure total weak acid. If we measure the hydroxyl group, this is usually measured through what? Through the dissociation of water. So the hydroxyl group will increase, and accordingly the B constant of water is 14, so the hydrogen ion will decrease, and this means the pH will increase. So this can be monitored by the pH will increase, and the strong ion differences will increase, give this some sort of alkalosis. pH is an alkalotic, but the change in the total weak acids and bicarbonate is the same. So this is a strong ion, the anion gap. When you look at the anion gap, sodium increase, but there is no change in chloride and the bicarbonate, so it will be more than 12. So this is a metabolic alkalosis with high anion gap. So this is a metabolic. Addition of sodium acetate will give strong ion differences will be larger, and the anion gap will be larger. This is a high anion gap metabolic alkalosis. And thank you.